Okay, some more advanced knowledge, I guess, videos in Excel, but mainly it's how to use Excel to develop programs of many types. This one happens to be just doing estimating um, for steel fabrication and erection, but steel fabrication mainly. So I'm gonna run down uh, what doing takeoffs in, I guess, in this program. Excel is obviously it's more customizable. Buying a canned program off the shelf, you have to use the way that their program is developed instead of making your own. That's why I go this route. So selecting items obviously is fairly simple here. So pretty much every AISC shape is available. I mean, when you're just selecting items, I'm not gonna go through all of them, but there they are. Tubes. Here's your tubes. The fast thing with this kind of an option is if something changes, it's it's easy to change the size and pretty much any item that's in here. But the plates I thought is kind of slick because it's varying in dimensional size and thickness at the same time, and the purpose of the plate. So if you select the generic plates item, so now here's just a descriptor which helps you to describe what the plate is when you're going back through the estimate, the takeoff, and all that, trying to figure out if you got everything, all the thicknesses. Oh, this spreadsheet or this program estimate is more of a higher level. Um, the place where I'm at, I made this for them. This is kind of their they did takeoffs and they're estimating just like on a generic like a bill of materials sort of a spreadsheet kind of format. Um, so I made it in this fashion, so it fit what they were kind of used to looking at, but because their jobs are a little bit more kind of more simplistic and on a much on a smaller scale, that this works. It works enough, you know. So that's why it looks like this. Um, anyway, okay. So there's your basic. Just you're just selecting items. You just select them steel related items, putting in the feet or the size of whatever. This is the feet for linear feet is similar to AutoCAD. You have to put in the feet symbol, 2 feet, space, and then the inches, and then it I mean this just converts it into the fractional versus the decimal. Uh, that just anyway, but it works similar to AutoCAD where you put the feet and inches. One of the things with this specific company, they we deal with a lot with getting drawings from overseas. So obviously they're all in metric. So I have a program that it's actually just a formula, but you can put in whatever metric in millimeters, and it just and then the next column over converts it to the imperial feet and inches. But when you're doing an estimate takeoff, uh, I had this option where so we're selecting an item. There's 10 of them, and then here's your millimeter inches. So let's say it's 1660. So it'll automatically give you the feet. Then it'll put in here the 1660, just as a reminder that piece, that's what it was in the metric, and here's what it is in the imperial. So of course it works for any item except for the plates. I didn't feel the need to, although I could do that. At this moment, I didn't feel the need to do that. So that's a time saver, but it's kind of a neat little thing. One of the things, the biggest thing with any program, and I don't know, FabTrol, I know they don't have this, and I'm pretty sure FabSuite doesn't either, but the ability to have assemblies, or since steel, we have the biggest thing is with the connections. So we have a beam, I'll have two different ones so you can see the how it works. So we're gonna have 15. All right, so this is being connected. Here's the connections. Here's a single angle, bolted, double angle, bolted, and then there's single welded, bolted, so it's welded to one of the either the main beam or the secondary beam. Same thing with this one. So now we have the double angle on. This is double angle on each end. So this calculates on each end, not anyway. So if we say it's going to be double to bolt, so you select a W10, and it's going to give you. Well, it didn't work. Oh shit, that didn't work. Why didn't that work? Oh, something happened. I don't know what happened there. I'm not looking into that. Here. So anyway, it gives you the length based on the size of the beam, and which is taken from AISC's. What if it was just that beam? Yeah, it was just that beam. I got to look into that. So gives you the length, uh, gives you calculates the bolts based on the the bolt requirements for this size beam and the angle. The angles then obviously you can select different sizes of angle. Um, I was working on something where you have bolted with slotted holes versus just the punch holes, and I don't know if that really is that much difference in time for hours, but I was trying to work on something. But then this will tell you what it is. It's a double angle. It's bolted. So it's a single angle bolted. And then if we do let's just do a channel. I'm gonna say it's welded. It's not gonna work. Single angle welded. This guy. So it gives you the quantities again. Here it is. It's a single angle to weld and bolted. So it's gonna give you the angle, give you the quantity of bolts. The length again is based on the size of the member. At the same time, there's also shear plates. So if we go to connections and we say shear plate, it's going to be this beam. Now it gives you the size of the shear plate based on the size of the beam. Because if I would let's do a 36. And then we do shear plate. So now you can see how it's significantly larger because of the beam is much larger. And then this just comes up with the 3/8 automatically, but you can change it to half inch, 3/4, whatever you want on the fly at any moment. Um, for scope items, I'm gonna do this there. Here, this is like the stair assembly stuff. Oh, over here, stairs. So here's, anyway, I'm just gonna do stair. So this just gives you a generic 30 degree riser, 30 degree stair, like a generic stair. So it's just number of risers, and it's gonna give you, just the basic items. And then this can be obviously changed and manipulated. This can be customized. If Now this just gives you the pan fill if it's an alternate tread. Now it's going to be a grading. There's there's supposed to be some other ones in here, but I'm still kind of developing that. Same thing with the straight ladder, more rungs. I mean, it's pretty basic, but it gives you all the items in a basic elevator pit ladder. It's fairly generic, but it can be custom. You can customize it to pretty much anything. Um, Handrails, something kind of similar. So let's say there's 25 feet of linear feet of the railing. That's handrail. That was handrail. Handrail, yeah. Railings. Here's railings. So 25 feet of railings. It's a 3-line rail, and I'm gonna give it 6 posts, and the posts are just 5 feet. And now this is where I can add a handrail, or I can just play 0 for no handrail, and no kick plate. So anyway, it's it's just one of those how assemblies work. You can quickly add multiple items into an assembly, and so it's easier to for doing takeoffs and backtracking. Um, so shop obviously fabrication labor times is always a factor, and how to properly budget your times. Um, for this one, because this is a higher level. Um, it's just a higher level kind of a estimating, environment. I go with the hours per ton. So you can see here's the hours. Here's the hours. We got 146 hours. Now this is based on a 15 hours per ton. Our shop, we have a small shop, and it's a lot of manual. They don't have very many machinery, so the fabrication hours per ton would be higher than a normal, like a structural steel fab shop. But let's just drop it down to 9. You can see how it brings the hours down. Again, this is higher level. It's not. This really isn't looking into how many plates are being welded and fit up and welded like my other program does. But it's definitely gives you right in the right range. It's easier to manipulate. So it changes the hours. Now I started this price index because of the steel specifically was going crazy there for a while. So here's your I would have like the baseline, or no, this isn't the baseline, but this is I don't know where things went, but right now it's at a price index of 35, and it was going way up. It was one time it was almost like a 75, so it was like crazy. But you can easily get some check your recent purchase orders, or you can get some quotes, and you can see on whatever the item is, where it's falling in, and what I guess the price index is. That's how I do it. That way it's within the proper range for purchasing the steel items. Um, So anyway, okay, so now this I'm gonna have another little video, but so this is just doing a simple, just pulling items from a database, putting in a spreadsheet, you know, for coming up with your number. Now because it's in Excel, you can there's many variables or options you can use. So this is the estimate. It can also be the proposal. I've done this for decades, where I have my sheet where I have my spreadsheet for my numbers, and then here's my proposal sheet. So it's all one document, and I can just save this, and then here's my scope of work, and the scope of work here pulls pulls from the bill of material sheet. So here you have stair. So what I'm going to do, let's do this. I'll do miscellaneous. Sometimes some companies do mis and structural, so they have to break them out, especially specifically in New Jersey. It's a big thing over there. So now on your scope sheet, I have to do MO1. So those are the items that are that I just put in here. Now this could be an alternate. If this is an alternate, let's see. Let's see. Where's my alternates? So it's gonna be alternate 5, scope sheet, alternate 5. There it is, and then that dropped out of there. That M. So just one more time, if I come back in here to this X, and then I do Z, there's your scope items. And in this summary page, now this is where it's gonna break down your estimate, your spreadsheet into your scope items that I just showed you. Then on top of that, you can have remember you have multiple scope items, but then there's also sometimes there's bid items in there. So this might be under bid item 1. This could be bid item number 1. And this one's going to be under say 4. So then whatever the description is will be down here. You have to every job's different, but then it's going to break it down properly based on this information here. I don't know how else to explain it. It's pretty self-explanatory. But here now you can see all your structural items. These are all your steel members, including including plate. Purchase items are pretty much anything that's decking, bolts, paint, you name it, that goes under purchase. Anything not a AISE member goes under purchased items for material. But you can see what the shop labor is, and then freight and the drawings and all that stuff is another just another takeoff item. So you know how much we're going to put in for delivery. So here's a description. So this is just generic deliveries back to the job site. Miscellaneous metals delivery. That's a description. Then here's your galvanizer. Make sure you have shipping into the galvanizer or the anodizer. Okay, big thing. Coatings is a big one. So I'm gonna come down here. All right, let's say this scope item is getting coated with paint. So here we have our coatings, and then here you have your options. What what specific kind of what's the prep? What's the coat? Is it a prime coat? Sometimes it's two prime coats, prime plus finish, and then here's the proper the surface prep, 2, 3, 4, 6, whatever, 10, and then there's obviously hours and the material cost is varies per whatever option it is, and this is how many gallons is required based on my calculations anyway, based off the square foot here. Here's your square feet of each member, so it automatically will do that for you. And what this is just the way this thing works is it's 23 gallons, but if it's a prime plus two coats, then I just up the material price to account for the uh, the the additional uh, yeah the additional material. So you could see the shop hours go up here. SSPC 10, it's very labor intensive, or you have to send it out to somewhere to get it done, so it's much more expensive. Period. So there's coatings. You could also do galvanizing. So let's say it's getting galvanized. So there's your galvanized. Just gonna add up all the basically the weight, and then you could add the shipping here in this scope item, or sometimes I'll have a one scope item that has all my deliveries in there and field and all that stuff. But there's your coatings, finishings, and so what I just showed you that it would this is only accounting for this scope one, scope one S1. So this one might be galvanized, but these access ladders could be just a prime paint. So this one's just gonna be prime paint. That's it. Just a real basic, nothing. So it's only accounting for this, you know, for these items. I don't have one for anodizing at the moment because I haven't come across it at this company, so I just didn't put it in there. Um, Now I did explain about the shop hours with the hours per ton. If something is a specific item that has a lot of welding, I do have some weld times. And so what do we have for that? Here's pretty much the this type of welds. I mean, here's like a standard, single pass, two pass. There's the thickness of the weld. This is more like a true fillet weld, like a if I don't know true fillet. This is just the passes going over it. This accounts for the volume, half inch by linear feet. So half-inch fillet versus three-quarter inch, 15 feet. Yeah, there's going to be difference in times, and this is always an area of discussion. I have lots of data on this, but anyway. Um, and with the welding, like you saw, so every one of these is another option. So we have standard, now we have shop is this a vertical weld? Is it an overhead weld? Then you have field, standard, typical, waist level, normal. Then is it a vertical weld? Is it overhead weld? So you'll have every one of these options in a vertical and an overhead, and then the hours that are associated with that work activity would be accounted for in that scenario. Let's see. Some of the other assemblies, again, these can be added to. So I got roof frames, right? These are, I don't know, they're always, they're not generic, but they're very similar in nature. Some angles and all that stuff. I mean, if if there's a specific type of roof frame that a company, your company, kind of makes, all those little items can be added in here. But you can see this has the fabrication, and then it also puts in at least some field time, which can be taken out or adjusted. And then another splice plates. So so now this is going to bring up this sort of menu, I guess. So what beam is being spliced, and then it's going to adjust in the plate sizes. I think thicknesses depending on. So it's always half inch. I'm pretty sure. Yeah, see there we go. It even adjusts for the thickness of the plate and the count and the top of bolts and stuff like that. Flange bolts, web bolts, and then uh, this is a carryover from a previous place I was, the way that they did their field bolts. Anyway, so adding a splice and making sure that you have enough bolts, because it adds up quick with the size beam and getting a fairly accurate size of plate. That's what that was meant for. We got bracing. Let's do a single brace again. Some linear item, some a gusset plate and bolts, and then some field time. And this just happens to select all the angles. Um, obviously you just go up here and you just select channel or W. So, you can. But this is just meant to have a basic single brace. It can be, obviously, like I said, it can be totally customized, very fairly simply. So if you have a double, it's just gonna have more. Okay. Oh yeah. So we just, again, I'm just randomly taking these items off to so you get a very simple overview of the program I created here, and what advanced knowledge looks like. So we all know steel items are, we have our cut list, we have our, then we have our purchase lengths. So to get that, I have to basically get all the items that are in the, oh boy, I went too far. Went too far. Anyway, it pulls in. Let's do this. me do it. I gotta restart this thing. Anyway, what this does is it brings over all the structural anything, all the structural items, and then here's all your purchase items. Here's all your bolts. The galvanizing, which is not but it's something that has to be a purchase order. It's got to be written. Here's your handmill brackets, and then over here, this is so now my nesting program. I just copy. This is all the neat takeoff. Plug it in. Actually, I'll just do it real quick. So here's my structural items I needed, and I erased the summary by accident, but it would just sum up to here again. Here's what I'll get based on our price index. Here's each piece. Here's a I mean 350s, 140, 135, and so it's a copy and paste. You don't have to retype everything in. Um, and then it would give you at least it will at least give you a close waste amount. And then go into the variables. Go to the bill of materials. Go to the in here. Let's go to the structural materials because this is what we're talking about. So if I do 50% waste, right there it added the appropriate amount for the waste. And then I can make sure that the STR is structural materials versus the purchased items, right? So I come here, and if I had this summarized here, this is almost 15,000, but it'll be summed down here say 15,000. So I just gotta make sure this is 15 more than 15,000 for the structural materials, and that would include the plate also. But then but that's just if it's a fast way to do the takeoff, get your order lengths, and then it's recorded again all in one document. Cover sheet. You have your takeoff, I guess you want to call it. Here's your summary of all the different scope items, where all your money is. This could be used for your schedule of values extremely easily. And then here's for your alternate items and your bid items and all kinds of stuff. This can be expanded upon very easily. Uh, I'm working on I'm working on a change order process that works similar to this. Um, it's just the change orders they're a little bit more kind of detailed, and but they're not as I don't know it's just, I don't know it's just something I'm working on. Um, yeah, let's see. But yeah, that's a good enough rundown of a basic, quick overview of what somebody who has advanced knowledge, who's done estimating and resource planning of many types, doing your forecasting, all kinds of stuff. How do you make sure you plan for everything, being able to summarize, your all your detail information to come up with uh, a decision, I should say, to what direction to go in. Um, I can go over more stuff, but most of it's just pulling off items, you know, out of a database. Uh, the biggest thing with this program really is taking it off quickly, very fast. We can organize it. It's way less labor, I should say, tedious than some of the other steel programs where you're very data entry driven. Um, and you can at least do the neat, like the cut list, I guess, and then do a purchase lengths. And you can put the marks in, and at least this nesting program will keep track of the mark numbers, and then we'll spit out a cut list. But it's not as clean as like Romac is, but it, for this application, it's perfect. It works seamlessly, I would say. Um, I showed you some of the assemblies, stairs. I showed you that a little bit, and just a very very quick overview of what this thing is. And again, this was made for my current opportunity, my current company. Um, and I did another one for a previous company, which was a lot more. They were more of a structural shop, so I had I had labor accountability accounted for each step of the process, depending on what what item was chosen. That's another video. Okay, thanks for watching.